you're going to want to start up Unity Hub, and from Unity Hub, it helps to have installed this version of Unity, or if you haven't got this one, Unity, any LTS version of Unity 2022 will be good. The way Unity breaks up its versions, because it can be a bit confusing and a lot of people complain, is that there's the LTS, which stands for long-term support, and everything else, which is the alpha, beta, and the ones that generally bug out. So you want to keep using Unity LTS for any personal projects, but for this tutorial we'll be using Unity 2022 LTS. Yep, and I've already got mine installed, so we're going to create a new project, and from the templates you want to choose 2D core because our project's going to be running in 2D, and choose a suitable name. So I'm just going to call mine rolling ball, and below that you can choose your location, so where on your file system you want it. The cloud organization, I'm not sure if you need to select one. I'm going to leave mine blank, and make sure you uncheck use Unity Cloud because these are services which are outside the scope of this tutorial project. So choose that. It seems I need to pick an organization, so you probably have one if you're logged in. If you haven't logged in, I'll just show you how. You click on the login somewhere, and you can use a Google account to log in. But anyway, back to the project. So Unity 2D core, rolling ball, select your organization, turn off all these settings, and check that you're using the correct version of Unity. So your LTS version that you chose to use is the right one, and create the project. So that'll take a moment or two to start, but I'll just go over what the project's going to be today. So it's going to be a 2D game, which is a ball which will roll across the level, kind of like those old Flash games if you ever played them, and that's the scope of the hour we have. So you'll be able to control it using WASD, and it'll reach the end of the level. Yep, and if we have time at the end, we might add some extra features like jumping or moving platforms. Generally speaking, because we picked 2D core, it'll be more lightweight than if we had gone for a full-blown 3D HDRP project, which might be something worth talking about. With modern Unity, so since 2019, I think they introduced render pipelines like lightweight and high definition render pipeline, which sort of break up what your high definition games look like and your more stylized games. So we're not using either of those. We are just using the legacy Unity renderer because it's the sort of, it doesn't have anything you don't need, especially given the scope of this project. Alright, so I've just landed. I'm not sure about you guys, but this is the first thing you'll see in the Unity engine, and right in the center you have your scene view. This will contain all of your your level. This is how you view it, is via the scene view. To the left of it you've got the hierarchy, which will store all the objects inside your scene, but in a more like a file hierarchy format. So you'll have a game object and its collider and anything else attached below it. To the right you've got the inspector, which is when you click on something you'll see all of its details and how you can interact with it. And at the bottom you've got the project folder, or the project window some people call it, but this is the literal file hierarchy of everything inside your project, and this is how you'll be able to find it. This is the typical layout of Unity. I use it as well. I don't think there's any need to change it. If you want, you can. I'm still reloading my scripts, but once it finishes I'll show you how you can reset back to this default, because if you do get lost and it doesn't look how it should, it helps. Here we go. So if you somehow rearrange your layout and it ends up looking all whack and you've lost a window like this, you can click on Windows and then Layouts and Default, and it'll take you right back to how it should look. So we're going to start our game by creating a new 2D square. Yep. So this is what is going to become our level. So the way I created that was by right-clicking inside the hierarchy and then going to 2D object, sprites, and here are a bunch of 2D objects. We'll also take a circle as well, which is going to act as our player, but we'll sort out the square first. So we want to select our square in our scene, so we can do it via the scene hierarchy, and then that opens up all the details inside the inspector on the right side of the screen. So every object by default contains a transform, which is sort of how it identifies itself in space. And you can think of it as its position, its size, and its rotation. So we want our ground to be looking a bit more like ground, so we'll widen it on its x-axis to make it look a bit like a platform. So you can change that to 10, or maybe 20 is more suitable. And then we're going to need to move it down so that it's not just sitting in the middle of the screen. So we'll choose a new y value of, say, -5. So that aligns it nicely at the bottom of the screen. We're going to do the same thing with our circle, which is going to become our player. We're going to center it by reducing all of its position values to 0. There's such a thing as the world origin in Unity, which is the 0, 0 point. And generally, that's the center of your scene. It's probably where your player is going to spawn, and it's where you're going to base everything. It's your point of reference. So the next thing we're going to look at is Unity components. So in Unity, the structure of a game is a scene, which contains game objects, and game objects which have components. Components are what give a game object behavior. So for our game, we're going to want our player to behave according to physics. And to do that, we're going to attach something called a rigid body. So anyone who does engineering probably knows about this. Rigid body 2D, because we're working in 2D. And now our circle object inside its inspector has a rigid body 2D. So the way I did that was I selected the circle, and inside the inspector, I clicked the add component button, and I searched for a rigid body. So that's the general process for adding any component. So just to review, we've got our circle inside our scene, our ground inside our scene, and a rigid body on our circle. So if we press play right now, the game is going to do something. There we go. The player's gone. He's fallen through the floor. See, that was something, but it wasn't exactly what we wanted. The reason for that is our circle and our square. The square does nothing, and the circle has physics, but the circle doesn't have collisions by default. And the fix for that is you need to add a collider. Like in a fighting game or any other game you've heard of, there's a hitbox, and the hitbox determines the physics. So to add a collider to our player, we're going to follow the same way we did for the rigid body. We're going to click Add Component and search for a circle. And there's a circle collider 2D. That's what we're going to use. There are 3D versions of all these components. Because we're working in 2D, try use the 2D ones. I don't think they'll work with 3D. And if we press play, we'll notice the player still doesn't collide with the floor. Why is this? Oh, it's because we've forgotten something. This happens all the time in Unity, and just because something doesn't work the first try doesn't mean Unity is broken. And I've often thought that, yeah, maybe it's the Unity's fault. Often it's just my fault, and I forgot to add something. So we've got our collider on our box, on our square I mean, which acts as our ground, and we've got physics on our circle, and on our player we have our collider. So if we press play now, we're going to see something different. We will see our player collides with the floor, which is the first beginnings of what will be our rolling ball game. We're going to add just some colors to our players and our ground so we can distinguish them a bit. So I'm going to give my player a nice green color, and the way you can change this is by configuring the parameters of a component. So the sprite renderer has a color parameter which you can change. So you navigate to your player object, which is the circle at the moment, find the sprite renderer inside the game component inspector window, and then click on the color, and it'll open up this nice color picker, and you can choose a color value, and you'll notice that your player immediately changes to that color. So this is a simple explanation of just how components can be configured. We'll do the same thing for the ground and give it a nice brown color. And play the scene just to see that everything's working as it should. And yep, we still have the exact same behavior. Next up, we're going to be creating the player controller script, which will handle turning player input into player movement. So to do this, we'll navigate to our project window, and we'll right click anywhere, and then it'll open a context menu, and then you go create, C# script. It should be near the top, or C# script for the non-initiated. And we'll name this, try and name it first time, player controller. You could name this just player if you want, for simplicity's sake. And it'll do a bit of reloading. And then you can open up the C# script, and it should take you into your editor, not editor, your IDE. Unity should come with Visual Studio Community. It just gets installed when you install with Unity. So I'll quickly code up this, but if you miss any of this, the code can be found on the document which has been shared on the Discord inside the events channel. It's called Unity Engine Tutorial. It should be the latest thing in the events if you're on the Discord. So on here, if you scroll down past everything we've already done, you'll find this box called player controller that's inside step 3. And this was the code we're gonna be using effectively. So if you know how to code, this will probably make sense, but we're gonna add a new variable called speed, and we're gonna add a reference to a component called rigid body 2D, because that's what we have attached to our player controller. So rigid body 2D, you should get nice IntelliSense suggestions. The normal notation, or the standard notation, is RB for rigid body, so I'll just be using that. And we're going to be using the player's input and applying that to the rigid body. So first things first, we're going to get the player input. And the way we're going to do that, Unity has a class called input. It's straightforward-ish. So we're going to use a vector2, which is basically just 2 float numbers, or 2 numbers. That's all you have to know about vectors. A vector3 is 3 numbers, and there is no vector1 because that'd just be a number. So we're going to use a vector2, which will contain our horizontal input, so A and D for WASD, or arrow key left and right, and it'll also have the vertical input. So we're going to call this input, and then we're going to define it. So this is inside the update loop, which is called every single frame. It'll do the update logic. And to get our inputs, we're going to write new vector2. Just going to let Copilot finish that for me, but I'll talk about it. So in the x value, we're defining our input and our new input value. For the x value of this input, we're going to use input.getAxis horizontal. So input is that Unity class I talked about before, and getAxis basically means A and D, or arrow key left and arrow key right. So it's an axis of movement which you can reference. We're also going to use getAxis vertical because that's your up and down movement. And now we've got our inputs. We need to apply it to the player object. And we're going to do this in the form of a force. So a force is what you'd expect. It forces the object to move. So we're going to use our reference we created at the top called rigid body, or RB. And we're going to use RB.addForce. And if this has arguments or parameters, and inside this you're going to put the input. So this is our input value we made up here. And we're going to multiply it by the speed. So this kind of makes sense if you think about it. So we're getting the player's input, we're forcing it onto the player, and we're multiplying that force by speed, which is how fast your player is going to move. The one thing you need to consider as well is, well, it doesn't really make intuitive sense, but time.delta time. So this basically stops it. Because this runs every frame, if you had the game running at 500 FPS, it would be much, much stronger than if you had it running at 60. So the time.delta time basically corrects for this inside the Unity engine to stop it and make it work the same on all computers. So this right here is enough to make our player move according to our input. Hopefully you've all got this typed up now, and if not, it is available on the doc on page 5. So we'll go back into Unity now, and it'll reload the scripts because we've made some changes outside of the editor. And we'll click on our player circle, and what we're going to do is we're going to do just like we added the collider and the rigid body. We're going to add a component, but this time we're going to search for player controller, which is our new script we just created. And it'll appear, and you're going to see it's got our two variables which we defined in the code. But one key thing, and this happens all the time when I'm making a game, there is no reference on the rigid body, which basically means there's a rigid body and we're going to do something with it, but we don't know what rigid body to work with. And this is fine. In Unity, you can just click on a component and drag it in, and now it's got a reference. So it'll say circle rigid body, which basically means circle objects rigid body. That's the one we're working with. And I know from experience we're going to need a lot more, not experience, but I've done this before, and 100 is a much more suitable speed, I think. Otherwise it just won't move, there's not enough force involved. So I'm going to test this and then come around. With any luck this will work straight off the bat. And the ball is now rolling, and I'm doing inputs. It's very slow. Maybe if you are more fast-paced you want to speed that up, but we're going to move on to the next part of this little game thing. So at the moment we should have our player able to move around the level, and we're going to start by expanding the level a bit and giving it some complexity. And to do that we're going to duplicate our original platform using Control D. And normally, so one option to move an object around the scene is to alter the transform X, Y, and Z values. And that is a numerical process, so you enter 1, it moves 1 to the side, you enter 5, it moves 5 to the side. But that's a bit clunky and not really practical if you want to build big levels, like I'm sure you want to do. So what you can do is you can click in the top left of the scene preview, this little move tool, and then these axes will appear on an object. And you can click on these arrows and drag them, and it'll move it up and down, or left and right. And if you click on the blue square, it'll move you anywhere along on that flat plane axis. So if you get lost, it's in the top left. There's also a rotation tool, so if you click it, these rotational things appear. There's a scale tool, so if you want to make it wider, taller, and there's kind of this all-in-one, but I mean, if you like it, you like it. If you don't, you don't. So we'll go back to our translate, and let's just try make a little bit more interesting of a level. So I'm going to put one here. I'm going to scale it up on the x-axis to make it like a bigger ground. I'm going to click on my original square. I'm going to duplicate it. Now this process is pretty arduous if you have a trackpad, and I'm not sure what to tell you then, but I'm going to continue building this like that. Also, if you really want to speed up your efficiency, the keys E, R, and W will swap between these three key tools of rotating, scaling, and moving. But if you just prefer a graphical method, the top left will do it. So I'm going to rotate this. And really, I'm just trying to make something a bit more interesting than a single platform. So maybe we'll put a jump over here. And that can be my level. Cool. So if we press play, if we do this, we'll notice a very obvious problem. We can't see our player anymore, and our camera is not following. So this happens sometimes, and if you just need to see what's going on, you can go back to the scene view whilst the game's running. So you see I clicked from the game tab to the scene tab. And I should explain a bit more. To move the camera, you can use middle mouse button. You can see in the scene view, the game is still happening, you just see it through a different camera, not the player's camera. But that's a problem and we need to fix it. So what we're going to do is we're going to create a camera controller script. So we're going to repeat the same process we used with the player controller. We're going to right click in the project window, create, C# script. And we're going to name it camera controller. Cool, and we'll boot that up. And we're greeted with the same screen we were when we first made the player controller script. And this time we're going to create a variable, which is important, called vector3 offset. And what we're going to do is we're going to define this when we first write it here. So we're going to define it as a new vector3, 0, 0, minus 10, which means on the x-axis it's 0, on the y-axis it's 0, and on the z-axis it's minus 10. This is important because for our camera, this offset is going to be basically where the camera sits relative to the player. So if it's sat right on the player, the camera's got nothing to film. But if we position it 10 units back, it's basically saying track it across the scene with a 10 unit offset. So we're also going to define a target. So back when I remember I said transforms, every Unity object has a transform. So we're going to use that to track where the player is. So we're going to call this transform player, and also we're going to make both of these public. I think I already did that in the player controller script, but the public is what makes it visible inside the Unity editor. So we have our offset and our player transform. And what we're going to do is every single frame, so inside the update method, we're going to set transform.position equals player.position plus offset. So that basically is what I was saying. By default, if you reference transform without specifying any other transforms, it'll assume, you must mean the transform that this script is on. So we're playing into that, where you have to put this script onto the camera, and then it'll offset the camera from the player, and it'll behave like our camera controller. So let's go back into Unity, make sure everything's saved. Back into Unity, it'll reload our scripts. Let's this time click on the main camera, add a component like we did last time. We're going to add camera controller. And it's not appearing. Why are you not appearing? Well, if that doesn't work, sometimes you just have to work around things. We can always drag our script onto the game object. And I'm getting an error. Now this is a common error I get, I don't know why, but it basically means it doesn't know what the script is, and the solution I found for this is unconventional, and it's an annoying Unity bug, but you copy the content of your script with Control-C. You may not have this. If you don't have this, that's good. Delete the script that we just made. And create it again. And we're going to call it camera controller again. This is seriously a really annoying bug, and I think it might be to do with my editor. But this time we're going to put it on first before we add our logic. So it dragged on fine. You could have searched for it like camera controller, and there it is. Open it up and paste our code we wrote before. And back in Unity land, it should be working how it ought to be working. So we have a similar situation as the player controller with its rigid body reference. We also need to give a reference now to the player, which is our target transform. So you can easily do this by finding your player object. We called our circle. So click circle inside the hierarchy, drag it over to your slot, your player slot, and it should, in a similar fashion to how it did with rigid body, say circle transform. Here it is, I know what it is. And now, if we start it up, our camera should be tracking the player. And it is, woohoo, yay. And now we can navigate our wonderful new world with our player that we made. And we can tweak all kinds of settings, like if we wanted to make our player a bit snappier. Though this isn't necessarily going to be snappy, it just means it's going to be faster and stronger. So yeah, I'm way off in the distance. I don't know where I went. We're gone. Anyway, if you've been following up to this point, you should have a player that can move, a camera that can track it, and a level that it can explore. The last thing we're going to add, or if we've got time, is a goal, which is like the player has reached the finish point. So what we're going to do is we're going to create a new game object and we're going to name it goal. Also, probably a good idea to rename all our objects. So circle is becoming player, and these squares, I'm not going to bother renaming them, there's too many. So when I created my goal, it ended up way off some random place, and I want to zero it back to the origin. And when I created mine, I just created an empty, which is fine because we're going to create some sub objects underneath it. So I'm going to create a sprite, a triangle, and I'm also going to create a sprite 2D object and a square. So what I'm going to try make is a little flagpole. So I'm going to scale it on the x-axis and make it a bit skinnier, so 0.1. And I'm going to rotate my triangle on the x-axis, hold on, wrong axis, on the z-axis by 30 degrees. And I'm going to click on the move tool and move it, and maybe I'll scale it down a bit. And I'm also going to color it. Remember, you can color by selecting the color value inside the sprite renderer. I'm going to make it a green flag. And that's going to be my goal point. So under a normal game development situation, you probably just get your artist to make you a goal sprite, but you make do sometimes. And for testing purposes, I'm just going to move this goal down here. And one more thing it's going to need is a collider. So we're going to add another circle collider to it. The circle collider is going to help us, so that we know when the player has hit it. So on the circle collider, we need to check is trigger, because that means that it's going to be triggering the script, which is going to be doing our win logic. So let's create a new C# script, and let's call this one goal. Alright, so the same familiar thing, we're going to define our variables. In fact, we probably don't need to define any variables for this script, because when we think about the script, what we want it to achieve is we want to have it so when the player object bumps into it, we want it to display text that says you win, or good job. So the way we're going to do this, actually, we're going to need a reference, and it's going to be our text. So we'll create a public game object, and we're going to call this win text, capitalizing the second letter just because of convention, not wint text. And we're going to make use of something called onTriggerEnter, which is a Unity-based event which triggers whenever an object enters a collider that's set as a trigger, it'll trigger this. So we can use this by using void onTriggerEnter. So we're capitalizing all of these, and it auto-filled for me. So if it gets an onTriggerEnter event, we're going to do winText.setActiveTrue. This is probably the simplest script we've had so far. So just going over how it works. We have reference to our winText. We have a message, an event. So private void onTriggerEnter winText.setActiveTrue. It has these default variables which we're not making use of, and that's fine. They can just exist. We don't need to worry about them. So we've made our goal script. Let's go back to Unity. And let's click on our goal object, and let's drag our goal component onto it. And we're also going to need to define some win text. So to create our winner text, let's right click and click UI, Legacy. So make sure you use Legacy, not the normal Text Mesh Pro. Text. and that'll create a new text object. We can click on this and it'll show us our familiar component window. And let's change this to something like "you win!" exclamation mark. So the way the Unity canvas works is a bit tricky, to be honest. But when you zoom out, you'll see that it's created this giant window and a little text thing in the bottom left. But that'll work fine for now. Let's go back to our goal object, and we're going to drag in our text legacy object. And we're also going to disable this text object because we want to start with it disabled. Obviously, you don't want to say "you win" as soon as you start up the game. So that was a lot. Let's just test it out and see if it worked. So there's no text. We roll over it, and there's still no text. What happened? Okay, so what happened is I didn't use the proper event. I actually used onTriggerEnter, which is for 3D games. What we need is onTriggerEnter 2D. The 2D and 3D stuff in Unity is very separate. But if we go back to Unity, and roll over our goal, it's really tiny, but down in the bottom left it says "you win." So we can correct that by turning our text back on. Just going to quickly zoom through this and then go around. Move this in the middle, increase its font size, and turn it back off again. We've actually reached the end of this tutorial, so it's been a lot. We've got a game, it's got a start, it's got some gameplay depending on the length of your level, and it's got an endpoint where it says "you won" or something. So at the moment, if you want to stick around, it has been an hour and 15 minutes, so if you're tired, but we can add some graphics because no game is complete until your artist has done something. So let's just start Googling. I'm gonna look for a smiley face or something and make my character a smiley face.
You still be part of this club.
So if you've found an image you like, you can bring it into Unity via two ways. The first way, which works better on mass, is to right click in the project inspector and click Show in Explorer. So this is literally Windows Explorer, so you can, or Windows or Mac if you're on Mac, I'm not sure how it works. But you can drag a file in and it'll appear inside Unity after it reboots a bit, and it should appear right there. The other way, which is probably more user-friendly, is you can just drag it from Windows into your assets folder, and then you've got your sprite. So the good thing about working in 2D is it's relatively straightforward to add a sprite to your player. You can literally just click him, and inside our sprite render where we've been changing colors, you can drag in the sprite to the sprite setting, and we'll have a big old smiley face. He's a bit too large. So yeah, this isn't actually a good idea to have everything on the parent object. It's a much better idea to split things via their sort of for what their responsibility is. So I'm going to remove the sprite renderer and add a sprite renderer to the child. Okay.
I'm actually pretty proficient with C# and something about new coding.
So you're telling me that Unity taught you how to code?
No.
No?
No. Okay, what's that Windows page? Oh,
Windows page?
it's good. It's good.
Thanks. Let's get a nice mountains. background.
You want to suggest resolution as well? Maybe do some cloud settings. That's fair enough. That's
I really don't like the tile palette in Unity.
I don't. Actually, what maybe forgot in Unity was specifically because tiles in Unity sometimes have this glitch where it like shows like a line.
Oh, that one.
And there's literally no way to fix that. And I was like, I can't fucking do it.
Oh, the way I fixed that was using the Pixel Perfect camera.
And I tried that, and it still didn't work.
Really?
Yeah.
I don't know.
So I was just like, okay, well, I guess.
I'm just kidding.
Awesome.
Damn, she's in the mountains.
It's the new Lord of the Rings game. Sweet. We rolling.
This makes me feel less splash.
Could we make multiple goalposts and you to get over?
Yeah. Yeah. Kind of. I hadn't factored these things in. I'm just gonna check and see if everyone's managed to get their iPhone.
There you go.
Yeah, so in Unity, the sprite renderer has this important order. So
I was watching the video later on, that's all.
He said that all the code is
minus 100. We'll put it.
Yeah. I have to open Unity again right now.
That's on you.
It takes so long.
That's all on you.
I'll do that later.
I don't know how I should feel about this, eh?
Exactly. That's a good thing.
Ah, yes.
Next up, I'm going to be adding the ability to have multiple checkpoints so we can make our levels a bit more detailed or a bit longer and just add to the gameplay a bit. So what I'm going to be doing, actually no, scratch that, I'm going to be adding a new type of obstacle because adding multiple checkpoints is going to be very tricky. Kind of. So we're going to start by creating a new script, and we're going to be calling this one Spinning Platform. And we're going to open that up with our code editor. Spinning Platform. Cool. And we're going to have a new float variable called rotation speed, and make sure that one is public. And then inside the update method, we're going to use the transform, and we're going to use transform.rotate. And we're going to use vector3 dot right. And we're going to be multiplying that by our rotation speed and by delta time. So What this script is basically going to do is it's going to make an object spin. That's the whole point of it, and that'll give us hopefully something more interesting in our game. So this is all you need, and let's go back to our game. Let's click on one of our platforms and duplicate it with Control D and scale it down a bit because it's too big. And we're going to add our component which we just made called rotating, actually what did I call it? Spinning platform. And with a speed of 100, let's see what it does. Just going to speed up my player a bit. Oh wow. That's
Actually pretty cool.
that's kind of cool, but also not what we're going for. So vector maths, well, just using vectors at all in Unity can be a bit of a trial and error process, but it seems we were spinning it on the wrong axis. So to fix that, we will use vector3 dot forward. And this time, let's just run it immediately. If it's not this, it's going to be vector3 dot up. There we go. So this is what I had envisioned. Oh, well, we made it. Maybe. And because it's an object we coded ourselves, we know that we exposed the rotation speed. So if we wanted to make it ridiculously fast, like 1000. Yeah, so just have fun with it and see what you can make. I think we've made a blender. So that marks the end of this tutorial. Thank you guys for coming. I hope you guys all learned something, and now you have the tools to make any game you want using Unity. Anything you like, anything you can imagine, you can do it. But yeah, feel free to message me on Discord and any of our other code mentors. I'm very happy to receive questions because I do this like a couple hours each day just for fun. So yeah, feel free to reach out if you have any bugs. I always like to help with those. Thank you guys.